Good morning from Philadelphia. Frank here with another edition of UFO News Network Sunday. This morning, joined by Dr. Michael P. Masters, who is, let me get this straight here, a professor of biological anthropology, researching hominin and evolutionary anatomy, biomedicine, archaeology, astrobiology, and the physics of human perception of time. That's a mouthful, Doctor. How do you keep it all straight?
Yeah, it's fun to be diversified, I guess. Get to dip into a lot of different areas of study and learn a lot of different things, but it's fun.
And basically, I came across your work as a result of an appearance you did on the Jimmy Church show a little over a month ago, a month and a half, 2 months ago, somewhere in that time frame. Got to listen to it. Thought, yeah, we need more guys like you in the field talking about UFOs and some of this speculative stuff. And what got you interested in it in the first place?
Well, I mean, it's funny that you mentioned that because there is a lot of speculation right now, and I think it's important to really acknowledge the role that science can play in trying to rein that in a little bit. That we can all say things, we can all believe things, but the science actually helps us get to the root of that. And yeah, I think it's unfortunate a little bit that the speculation has sort of driven a lot of academics away, but that really doesn't have to be the case. We can still approach these things and understand these things with an empirical, testable hypothesis, and that's a big part of what I'm trying to do here is present a hypothesis that's unique in the sense that it is testable. A time travel explanation for the UFO phenomenon is one that's testable by time itself. And I think kind of moving into this area, there's actually been a little pushback from some people that are really staunchly into the extraterrestrial hypothesis. But I think that having this different approach, it doesn't need to be that these are mutually exclusive necessarily, but there's still ways to sort of approach this question with an understanding of science and move the field forward, and then hopefully in doing so bring more researchers, more academics into it that have been somewhat put off by the rampant speculation within this particular field of study. So I guess my role, my hope is that by moving into this area that we can sort of develop a broader conversation among people in academia, also the UFO community, and sort of bridge an unnecessary gap that's formed around this.
Okay. And when you say a testable hypothesis about time travel, how would you go about doing that?
Well, like I said, it's testable by time itself. If
Okay.
I don't make specific predictions about when exactly we will develop this technology to be able to return to the past based on specific craniofacial features of what I refer to as extraterrestrials, replacing ter for Earth with tem for time. With that in mind, the features that they have, the craniofacial morphology, as we call it, is certainly different than our own. I mean, there's a broad range of descriptions of these individuals, and the main thing to keep in mind is that they have the same craniofacial bow plan of hominins. They're clearly bipedal. They walk upright. I haven't seen any descriptions of quadrupedal or six-legged aliens or anything like that. But the fact that they have that same characteristic that defines us, that defines the hominin lineage as a separate cladistic group in phylogenetics or the study of evolutionary relationships, taxonomy, the fact that they have that trait alone is a very good indication that we are closely related. And then you look at the characteristics of the face, the mouth, nose, eyes are all in the same place, brain on top. But probably the biggest indication of this is the fact that they have traits that are an extension of the same 6 million year evolutionary trends in our own hominid lineage. The two biggest ones, in addition to bipedalism and adapting to that characteristic itself, is an expanding brain, a brain that becomes more bulbous, more globular, as we call it. It's moved out over top of the eyes. We're one of the only mammals with that craniofacial configuration. The face has shrunken back. The eyes and the orbits have sort of varied over time. I actually did my PhD thesis on size and shape of orbital anatomy, the bony eye socket that houses the eye and other ocular soft tissues. And if we look at all of these traits collectively, the trends that have characterized the last 6 million years of hominin evolution on this planet, projected forward, are exactly what are described in the vast majority of these abduction accounts, just close encounters of whatever kind where these individuals were actually observed. So that's a big part of it. And in that sense, projecting those things forward, connecting our present point with that of the future based on this linkage and the anatomy of these individuals, it is a prediction. It's both a prediction about a state of humans in the future, but also an observation of that state at this time as a result of time travel technology itself. It bridges those gaps in the fourth dimensional continuum. So I say it's testable because if we continue to exist on this planet, we will eventually reach a point at which, if this hypothesis is correct, we will become them. And in that sense, we can very simply test whether or not it was, at that point in the future, will have been an accurate hypothesis or not. Because if we're not, then the hypothesis has been falsified. If we are, at some point in the future, the ones with these specific anatomical characteristics, and we are traveling back in time and researching ourselves in the past, then that this extraterrestrial hypothesis will have been validated.
And can you ballpark how long you think it might take to get from where we're at today to looking like, I guess the prototypical ET gray? Because that's the description you seem to be describing there.
Yeah, it is, and this is something that I guess I haven't addressed well enough in the past because I keep hearing sort of critiques of the idea based on a lot of people like to separate the grays from these other extraterrestrials. I think they're all a part of the same phenomenon. But if I guess a good way of looking at this would be if we went back in time and we went back 10,000 years in the past, say we went back 100 years in the past.
And we would do that in a heartbeat if we had the technology.
Oh my
Obviously.
God, absolutely. As an anthropologist who's worked around the world, doing archaeology, blasting through rock in South Africa, digging through, cave roofs that collapsed in dirt, Neanderthal sites in France, and out here in Montana, Native American sites. Yeah, I mean, I wish for a time machine every day when it's 95 degrees and humid and you're digging through the dirt. So there's no doubt that anthropologists would make very good use of this technology. And we can come back to this later if you'd like, but I think that's mostly what's happening here. It seems like very much research being conducted on us in the same way that we would do it. But yeah, so going back to this issue of the variation, the morphological variability among these extraterrestrials, if we went back 100 years, we'd get out of our time machine, walk around, nobody would have any idea that we were different. Our clothes would be different. We would speak slightly differently, but we'd still speak the same language. We'd look exactly like we go back 10,000 years. Obviously, more cultural things are going to be different, but we're still going to look the same. We go back 1.5 million years. Now we look very, very different from the Homo erectus individuals we encounter. we go back 6 million years to some of the earliest hominins, Roarantuganensis or Ardipithecus ramidus, whoever we encounter at that time, and we're going to look extremely different to these individuals. So I think a lot of the variation that exists in these UFO reports is, I mean, it could still be sex variation. There's differences between males and females. It could be age variation to some extent. Obviously, 4-year-olds look different than 90-year-olds. There could still be some geographic variation in the sense of what we used to refer to as race, this idea of geographical ancestry, where people in East Asia look different than Native Americans, people in Africa, and so on and so forth. But I believe in the context of a time machine, though a lot of it could be temporal variation as well, that we have differences among these individuals who we see at this present time as being variable, but they could have come from different times. So theoretically, you could have someone picked up by an extraterrestrial from 10,000 years in our future, later that day be picked up by someone from 1.5 million years in our future. And those two individuals would look very different from one another simply as a result of phylogenetic change across that 1.5 million year period between 10,000 years in the future and 1.5 million years in the future. So to some extent, that physiological variation could be in part a product of temporal ancestry as much as it is geographic ancestry or age sex variation as well. So it's hard to make a prediction. We have this problem in looking at the fossil record too. We don't have a representative sample of every single individual, every single time period. We have a ton of fossils. And it's funny, whenever we say that, people are like, oh, there's holes, there's gaps in the fossil record, there's missing links. And that's not true at all. We have a very good, long picture of the hominin fossil record. But we don't have every individual that existed at every time in the past. So when we find a new fossil, we have to account for age variation, sex variation. There were different species and subspecies around at many points of our past too. So there's also interspecies variation that we have to account for. And that makes it hard in the past, but it also makes it hard in the future. If we're getting snapshots of individuals from different periods in our future coming back to investigate us in our past, how do we determine that archetypal form? You know, how do we determine what that type specimen is if we're getting different shots of time each time we're being visited? So I guess a very loose answer to your question would be, I don't even know. It's so hard to say, and I really try very hard not to make predictions in the book that aren't rooted in something. And this is what I do for a living. I study hominin craniofacial anatomy, so I feel like I'm in a very good position to make that prediction. But there's just so many factors that go into our evolution and our change that, you know, in looking at the past, we can identify certain things that contributed to this unique form that we have, the big giant brains, the small faces. Projecting that forward, you know, it doesn't even seem to really matter what's shaping it per se, because it's persisted over such a long period of time that it's, regardless of what is driving the runaway brain, it's probably going to keep going. And especially, you know, things like cesarean section, sort of an important aspect of maternal and fetal health that you wouldn't really think would have much implication for future human evolution. But we suffer from something called the big head, small hole problem. And upwards of 25-30% of mothers died in childbirth, giving birth to large-headed babies, mostly because of obstructions during labor, not being able to pass the baby through the birth canal. And that, over evolutionary time, was a huge factor in keeping our brains relatively small in utero. And we do most of our brain growth outside of the uterine environment, which is also beneficial because of culture. We can grow our brains at a time and in a very stimulus-rich environment while our brains are growing the fastest at that time as well. So just being able to take the baby out with cesarean section relieves that selective pressure, maintaining a smaller amount of in utero cerebral development. We no longer, if we continue to do this and it becomes the standard way in which we deliver babies, and in fact, someday it may be the only way we can deliver babies if our brains are having that pressure relaxed and we are able to grow them larger. So there's a lot of things like that, sort of, and that's why anthropologists talk about this in the context of biocultural evolution, is it's not just the biology and this biological evolution with humans, it's also cultural. That cultural ability to cut a baby out of its mother isn't something other animals can do, and
Right.
we evolved to those cultural things too, like lactose tolerance because we drank milk, and just the frequency of the HBS allele associated with malaria because of agricultural changes and slash and burn and different things that we've done culturally have changed our biology. So looking forward, there's so many of those things that could impact it, but it does seem that we're still moving in that direction, that our brain shape is changing. We're getting these balloon heads, and when that happens, our face has to get out of the way. Those two things are linked biologically, what we call integration, craniofacial integration, where because our brain's the first to grow, it expands outward, forward, and the frontal bone expands forward. The anterior base of cranium sets the template for the rest of facial growth. So as our brains grow larger, our face just can't get bigger, and that's largely why our faces are small and why they've gotten smaller over evolutionary time in association with our expanding brains. So if those continue over long-term future human evolution, we would expect to look exactly like what these individuals look like, and those are just some of the many characteristics addressed in the book that link our evolutionary past to our modern form to what is our presumed future evolutionary form at whatever point or points in the future that may be.
Now, with the eyes seem to be getting bigger in these descriptions. Do you have an explanation for that?
Yeah, actually, it's really interesting you bring that up. I've published a couple papers in the Journal of Anatomy and one in Medical Hypotheses and some other places where we look at the relationship between the brain, the eye, and the orbit specifically, and looking at evolution of the orbits throughout grad school and since as part of sort of the main area of research that I do. I began to wonder about certain conditions like juvenile onset myopia, astigmatism, and some other problems that humans have with our eyes, being that they are a soft tissue circumscribed by a hard bony orbit that's being modified by the brain above it. And with our faces contracting, retracting, and also reducing in association with the brain growing out above, it sort of made sense that there would be some malformations of the eye that would happen in association with that would become constricted by an expanding brain above and a reducing face below. So we've worked doing some research in geometric morphometrics, and I study MRIs in my lab. And we are looking at what characteristics of the eye associated with myopia and some of these other negative characteristics, these negative traits, how they may relate to that. And if you look at the myopic or myopic eye, it does have very telltale signs of that constriction. It's elongated. It projects out forward, out of the orbit. People that have juvenile onset myopia, they have larger eyes that are more axially elongated. They're extended from front to back, and and these things. In the context of growth and development, the eye itself is very much a product of the brain. It grows out of the telencephalon of the brain during early fetal ontogeny or growth and development. So as the brain gets bigger, we would expect the eye to get bigger too. And unfortunately, the eye doesn't preserve in the hominin fossil record. It's a soft tissue. It goes away. We still have the orbit, and we can see how that changes. And it has, especially over the last 800,000 years, sort of constricted and changed shape. If we look at the Neanderthals or the Denisovans or any of the archaic Homo sapiens, they have these big, massive eye orbits and these big, massive brow ridges. So there would have been plenty of space within the skull for the eyes in these specimens. But with modern humans, we have larger not necessarily larger brains than Neanderthals. They're about the same size, slightly smaller in some cases. But the shape of our brains changed, and we have more forward projection of the anterior lobe of the brain. And the eye grows out of that. So having larger eyes would be an expected correlate of a larger brain throughout future human evolution, simply because the eyes grow out of the brain and they grow together throughout ontogeny, throughout growth and development in one's lifetime. And we would expect, again, we can't test this in the fossil record because the eyes don't preserve, but we would expect that as the brain increases in size, the eyeball also increases in size. And projecting that forward, that would help explain why these extraterrestrials are ubiquitously described as having very human eyes, very large eyes, much larger than ours, but in accordance with their larger brains, that characteristic would be expected.
Yeah, and the prototypical ET. The prototypical ET that we're talking about here, those eyes don't seem as well protected as the eyes that we've got. I used to play a little bit of hockey, and those protective brows come in handy once in a while as far as protecting the eye. And
Yeah.
you don't really seem to see that in the way these ETs are described. So they'd have to be a lot more careful in order to avoid some devastating eye injuries. They wouldn't be able to play hockey or a lot of other things, I would think, or boxing, something along those lines. A lot of activities would seem to result in some eye damage there with that kind of morphology.
Well, partly, yeah. But at the same time, we have a pretty evolved culture for taking care of the problems that biological evolution has presented us with. So, an example would be the problems we have just with standing upright with our knees, our backs, our hips. And we found ways to adapt to that. We can use canes, we can use wheelchairs as we get older, and our bones and joints just can't support our bipedalism and our body weight. So, I mean, I think they still could. They'd probably just have to rely on eye protection a lot more, and obviously bigger, sort of giant aviator glasses type forms of protection. But I mean, even there's also a common thing. And I try not to base too much off of the reports themselves because, that's the thing that's a little more uncertain. There's obviously a lot of people who have witnessed these things and experienced these things, and to them it's a part of their reality. It's an obvious fact of reality. For other people who haven't, including myself, I've never seen a UFO or anything. It's harder to really tangibly say this thing's happening, and so I don't base a lot of things off of that. There's a couple chapters where obviously it's tied together in the context of long-term human evolution, but one thing that is pretty common in these reports are these big dark eyes, black eyes, and there's one interesting example in the sort of famous, notorious, depending on your viewpoint, alien autopsy, where the individual's laying on this table, and it's a recreation of an event that took place in 1947. It's not the actual one, though there is some footage in there. But one interesting thing is they pull off this dark contact lens from that individual,
I remember
and
that.
yeah, and in doing so, you see very human eyes. I actually have a picture of that in the book to demonstrate how not only is this most likely a contact lens phenomenon in this particular case, but also just how much more human they look when you take that lens off. With a big black eye, they look like an insane alien form. But once that lens comes off and you can see the pupils and the cornea and the whites around the eye, which is a very human characteristic. Most other primates, even our hominoid ancestors and hominoid cousins alive today, have very little white showing in their eyes. But us humans have a lot, largely because our eyes are bigger. Also, the shape of our orbits have something to do with that. But simply taking that lens off causes this individual to instantly look much more human. And so I think, in addition to our eyes getting bigger, that common characteristic of the deep, dark black eyes is probably the result of context, and might come back to your point too about protecting our eyes. Maybe we need more protection in our eyes in the future because of any number of things that could happen. But yeah, it may be a vision thing too. It could very much be the same vision problems that we suffer from now, arguably because our brains and eyes have been getting bigger in a constricted face. Maybe they need them to see in the same way that we do. I have contacts in right now and don't know how well I'd function without them, to tell you the
No,
truth.
I think I'd have a lot of trouble living during prehistoric times without corrected
Yeah,
vision. It would be tough. I
it
think
would be very
the,
tough.
the saber-toothed tiger would see me before I saw him. That's for sure.
Absolutely. And in the I wrote a paper in 2012 in Medical Hypotheses about how it would only really be a factor in recent human evolution, because you would have selective pressures weeding out those with poor vision that didn't see the saber-toothed cat coming, for instance. But then not only that, once we started to domesticate ourselves after the Neolithic Revolution, once we got agriculture and diversified, now you have people that can do near work activities and sustain themselves that way. They can be weavers, or they can pound metal. They can, even with stone tools. Even before that, people could have just made their really good stone tools, developed really good knapping skills, and then traded those tools for meat and for other things that they couldn't get themselves because of this visual deficit. But also just in the anatomy, it's only recently in human evolution that we've had these brains move out over top of our eyes and our faces contracting. So I think, yeah, throughout most of human history, the vision problems wouldn't have been an issue. But now, and likely in the future, because we have this culture to correct for a biological problem. It's an evolutionary trade-off, is what we call these, where we've traded, a big brain for poor vision. We've sacrificed our vision. We've sacrificed a lot of things with our dentition. We have overcrowding. We have wisdom teeth that get stuck. We have problems with sleep apnea because of a constricted airway. We have choking. We're one of the only animals that can choke and die because we've put this big bend in our throats as a result of standing upright and having to rotate our heads down. So we have these cultural mechanisms to help fix some of the biological problems that we have because of our unique physiological form. And I think going forward, the contacts and glasses, as long as we can continue to mitigate the negative aspects of that, it can very much allow it to exist, but without being, anything more than just a giant pain every morning, putting them in and taking them out at night, I guess.
Now, one thing I did a few years back, I don't live too far from Independence Hall in Philadelphia, and I'm able to get down there once in a while. And one thing that is really striking, they still have the same desk. I mean, this is not even 250 years ago. They still have the same desks at Independence Hall as they had back when the Declaration was signed, and you really notice right away how much smaller people were
Uh-huh.
back then. And
Yeah.
I mean, in just 250 years, we're a lot bigger today than we were not that long ago. It seems like we can change pretty quick when we sort of put our unconscious minds to it.
Yeah, I mean, it's not really a conscious thing. It's just a product of our environment. And it's kind of an interesting thing, height. I actually just got done editing that section of the chapter last week. But height's kind of interesting because it varies tremendously over evolutionary time and even in a short-term capacity, like you just acknowledged. So like you go back 1.5, 2 million years with some of the earliest Homo erectus individuals that lived at that time, and they were about the same height as we were. The Narikatome boy, Turkana boy, KNMWT 15,000 for the nerds out there. He was about 11 years old, and it was projected that he'd be about 6'1" when he
Okay.
reached full maturity, which is very much within the range of modern humans. And you also have, I mean, even at age 11, he was predicted to have been in the 97th percentile for a large sample population of modern humans, a sample population of 11-year-olds. So even without that prediction of what height he would be at the end of growth and development, he was still very, very tall for an 11-year-old. So it's fluctuated a lot over evolutionary time. But once we get into the more short term historical changes, we have been getting taller. There's no doubt about that. I think the Dutch are the tallest people in the world, and there's a lot of data that shows that over the last 50 years they've gotten much taller as well. But it also varies based on your socioeconomic status, major events taking place. One of the first research projects.
Not to interrupt, but does that, when you say socioeconomic status, that relate to diet?
Yes, absolutely.
Okay,
That's
okay.
one of the biggest correlates is diet. One of the first studies I worked on as an undergraduate, actually, at Ohio University, was a stature study looking at socioeconomics, people's occupations as a gauge of socioeconomics. The other big factor is education level, but looking at their height and their anthropometric characteristics, their body height, stature, arm width, things like that, in the context of their occupation. And the results of that study and many other studies have shown that people that have higher incomes, that have better access to a good diet, tend to be taller people. And the whole population. This is one of the best indicators of a population's health is stature. You look at World War One, the Great Depression, World War Two. We see these rapid dips in people's height as a result of just food shortages and people not reaching their genetic height potential because the environment has subjugated their ability to do that. So yeah, and looking at people 100, 200 years ago, we've definitely gotten a lot taller over that period of time. But it's important to also consider the whole history of stature and of even human evolution, and really it's just there's a lot of fluctuation. We've been tall, we've been short. Even now we have modern human populations that are very short. We have pygmies, for instance, Homo floresiensis. This may have heard of this species found recently on the island of Flores, known as the Hobbit.
Yep.
But they're only about 3 feet tall, three and a
Okay.
half, maybe 4 feet tall. But they lived as recently as 40,000 years ago. So we have a lot of variation in height throughout the world and throughout time as well. And I mean, even looking at the future, if we can base some idea of what we will look like in the future on these reports of close encounters, there's a lot of variation throughout the human future too. It would seem some individuals are reported as being very tall. Others around 5 foot seems to be a common description in a lot of these reports. So yeah, height's an interesting thing. It really varies quite a bit across space and through time as well.
Now, you've been talking about some of the human precursors and early humans. Human beings really aren't all that old. For a long time, that 200,000 number sort of held together. And within the last couple of years, there was a report of a human being that was 300 years old. That's quite a jump further back into the past. What did you think about that when that news came out?
Well, I think it's important. And I hear a lot of people sort of talk about human evolution in these discrete categorical terms. It's important to keep in mind that it's a continuous change. There wasn't really a time, we can't say exactly 200,000 years ago we became humans. That's when modern humans were born, Homo sapiens sapiens. And I hear some commentators talk about this sometime about, what happened 200,000 years ago. Well, nothing really. I mean, it's all continuous. It's all in the same way that if you went back and looked at your ancestors over 5 generations, you'd see slight changes in how you looked and how your lineage looked over that time, and you'd pick out traits that you have that your grandparents and great grandparents had, and so on and so forth. But winding that clock back even farther, it's really a long continuous thing, and a lot of people make the mistake in looking at this continuum by breaking it up into these categorical terms. So it's hard for us as anthropologists because we have to give things labels. We have to say this is when we became anatomically modern, and in doing so, people take that as boom. That's the moment when humans arose. What was it about that moment? But it wasn't a moment. It was just certain traits came about and developed to the point that we can say, all right, these traits were different than the traits of their ancestors farther back. But there's not one point where we just got a chin and we just got a bulbous globular neurocranium. Those were changes that were happening slowly over time. So yeah, I'm never surprised when we modify the age slightly, and 100,000 years sounds like a lot, but really it's not. It's a blink of an eye, and most of us that are in the camp of the multi-regional hypothesis, which is the idea that we didn't develop during one major speciation event in Africa around 200,000 years ago, but rather evolved slowly from archaic Homo sapiens into modern Homo sapiens throughout much of the old world. We had been advocating for 300,000, even 400,000 years for much longer. And again, it's a continuum that we can't put a specific date on. I think a lot of that came from the mitochondrial DNA and this out of Africa, this African Eve hypothesis, which put us in Africa, modern humans, I mean, at 200,000 years ago. But no, the research now is starting to move more toward our multi-regional side, that it wasn't this one brief event. It was a slow, continuous evolutionary change from more primitive Homo sapien traits to more modern Homo sapien sapien traits throughout that 200 to 300,000 year window. So there wasn't really anything too tremendous about it. We were always doing the same things. We're still hunter-gatherers. We still had big brains. There were more species alive at that time. It wasn't just us by any means. But as far as our toolkit, our culture, it was all just kind of evolving at the same slow process. And certainly, with our bigger brains, our chins, our smaller faces, we were able to identify certain traits that make us, more like we are now. But even looking at now is a snapshot in time of our whole evolutionary history, just because we're the ones looking back on it. And I would argue now, looking forward toward the future, we're still just one small part of that very large, continuous 4-dimensional change in human evolution. So, in 100,000 years, 200,000 years in the future, they'll probably be looking at us just as some average humans that were doing very primitive things with primitive technology, and in the same way that we would look, back 200, 300,000 years in the past. So no, I'm never really surprised, and especially with that one, because like I said, I and many of my colleagues had already been on the more, long-term, multi-regional evolutionary
So
side of things.
you're suggesting then that humans developed in multiple locations, not just in East Africa, but the humans arose a number of different places around the world, more or less simultaneously. Then.
Yeah, and it's certainly not my suggestion. The multi-regional hypothesis has been around for going on probably 40 years now. Milford Wolpoff was probably one of the biggest proponents, an anthropologist in the 70s, 80s, 90s. He's still doing work, I think. But yeah, it's two different models to explain the same sort of rise of Homo sapiens sapiens. And again, you could take a human from 100,000 years ago and one from 400,000 years ago, and they could most certainly reproduce. So from a biological species concept, they weren't different species. There wasn't anything about humans at 200,000 years ago that, boom, made us different. We were still the same, just doing the same things. But we as anthropologists have to have labels. We have to make discrete categories out of continuous change. And it's obviously impossible to do. You can't just draw a line and something continuous and say, there it is, that's when it started. But our window of change for when we became modern humans, yeah, it did occur. There's more and more evidence. The morphological evidence, our physical form, has always backed up this multi-regional hypothesis. It was mostly the genetic evidence, rewinding the genetic clock, that put us in Africa at 200,000 years ago. But that model has always been criticized, and now with the recent study that you pointed out and other research, it seems to be falling out of favor even more so in recent times. So yeah, the other explanation, I mean, there was Homo erectus left Africa 2 million years ago, populated all other parts of the old world over time, even existed as recently as 25,000 years ago in Java. So we had people coming across the Bering Land Bridge into the Americas at the same time Homo erectus was still in existence in parts of Southeast Asia. So that older model mostly focuses on Africa, but after Homo erectus left, we evolved slowly from Homo erectus into the Denisovans and towards the Middle East, Eastern Europe, the Neanderthals in Western Europe, East Africa or East Asian Homo erectus developed more modern characteristics into what we call archaic Homo sapiens, and then that shift from archaic Homo sapiens into what a lot of people refer to as humans, what we call anatomically modern humans, occurred just as a slow process in many of these places, and what allowed us to do it collectively, what allowed us to become one modern human population was just gene flow, reproduction among neighboring groups, and then because we had reached critical mass, so to speak, we reached a large enough population that interbreeding among all of these smaller groups throughout the old world helped link us together in the same way that we are now. I mean, we now exist as one large interbreeding population throughout the world, and that migration among different groups and interbreeding with other people that they came across throughout Asia and Africa and Europe allowed us to maintain genetic homogeneity across those different regions. The Neanderthals died out, but we also know that we were interbreeding with them too, because roughly 5% of the modern human genome is Neanderthal. So there was a lot of moving and shaking. There was a lot of interbreeding, and we were able to just evolve slowly into modern Homo sapiens throughout this 200 to 400,000 year period, but without one particular thing happening at one particular time. It was just a slow slow evolutionary change. And well, that's more boring. Well, well, it's not as interesting as, oh, wow, what happened 200,000 years ago? Or, what happened 20,000 years ago? Nothing happened. It's just that's the point at which anthropologists say this is when we develop these traits that make us classified as Homo sapiens sapiens.
Okay, so it doesn't seem likely, based on what you're telling me, that there was some kind of advanced interference in our progress. That this is a natural process. That there is no point at which either time travelers from the future were able to go back and speed things along a little bit and make the humans of those days a little bit closer to modern human with the intellectual capacity, or maybe somebody from some other planet. That humans are just spread too far, too wide. Doesn't seem like it would be possible based on what you're telling me here.
Well, in the context of a time machine, it would certainly be possible. But it doesn't need to be. We don't need that explanation, because if you look at the pace, the rate of culture change and physical change, there were no big jumps. There was no indication that we got this flood of future genes or this flood of future information in our culture. We were just getting smarter and more culturally advanced, and we were developing these traits that we have today and presumably are going to have even more so in the future. So, I mean, it's certainly easy to say there could have been contact, there could have been influence, but I mean, think about it this way: if I was going to go back in time as a paleoanthropologist and study, say, the Neanderthals, 150,000 years ago, I would take fecal samples, I would take blood samples, hair samples, I would take some samples of their cultural materials, the material remains that we are able to investigate archaeologically, but we can't look at any of these other things. We don't have that soft tissue. Like I said, I would measure their eyeballs. That'd be the very first thing I did.
Right. Okay.
Because we don't have the ability to do that. So going back in time, we have the ability to learn so much more, but I don't feel like we would want to change anything. And it wouldn't be changed because of linkages and self-consistency. It would always have been there, and the results of anything that we did would always be in our future too. There's self-consistency among events, so we wouldn't be changing anything. But we would try not to interject ourselves too monumentally in that culture. Even if we did, it doesn't really matter. They didn't have writing. They weren't carrying around cell phones where they could take pictures all the time. Their art, there was some, cave art at that time. We actually just recently found evidence of Neanderthals doing that within the last few months. But, they're not really going to be able to transcribe our existence and their time in any meaningful long-term way. However, we go back, 200 years ago, we go back 10 years ago, suddenly we're going to be interjecting ourselves into a culture where we can be recorded much, much more in a more archival context that lasts for long swaths of the future. So I tend away from an interjection and influence sort of thing. Again, in the presence of a time machine, that would be possible. But I think people coming from the future to study the past would have strict limits on how deeply they can really engage in or interact with the past. Certainly, like if the Roswell crash in 1947 took place, that's a pretty big interjection that seemingly was unintentional. I don't think anyone would intend to go back and die in time travel research capacity. But that accident may have huge ramifications for our ability to not only develop a technology, this disc or triangle shaped craft that's able to use a non-vector propulsion system, probably something electromagnetic based on reports that allow it a a much better ability to maneuver and fly and the speed and all of these things that we see all of the time, even being tested, in different places. There's lots and lots of videos, authentic videos of that. But that would have to be considered a major intervention, not an intentional one, an unintentional one, but certainly something that would not only give us that leap forward in our technology, but also, and this is kind of a mind-bending aspect of time travel, also help create the same time machine that was used to come back and crash at that time, which was then used to create the same time machine that then comes back and crashes at that time, and so on and so forth, which creates this interesting scenario. It's not a paradox in any way, but an interesting scenario in which the time machine, if this is the actual case, if there was a crash in 1947 and we do develop time travel technology partly based on this machine from the future capable of time travel, then no one created it. If it was given to people in the past who had no knowledge of it, but they reverse engineered it and were able to create it to the point that it becomes the thing that starts that creation again, it's really hard to say that this person invented time machines, because it's always been a part of that slice of fourth dimensional block time, without any clear beginning as to when it was created outside of the context of that crash. So yeah, I think, there's a lot of reasons why we wouldn't want to interact too overtly with the past. And in fact, this helps explain why UFO sightings are so so few and far between. Why would somebody come from a different planet, millions of light years away, to pick somebody up and anally probe them and take some blood samples and hair samples and then just leave, without saying, hi, I'm from planet X551 and this nebula and this place. I mean, a big part of the book points out just how improbable it is that we could ever find each other, if there are the distances in between, which are real physical limitations. A lot of people try to downplay that, but all the astronomy physics research pretty clearly states that it would be extremely difficult to get anything to another galaxy in any meaningful period of time, let alone the whole problem of evolving on a different planet and what would we look like? We certainly wouldn't look anything like us. Some people like to argue that there's DNA, there's genes, and things just unfold in the same way. But there's so many unique aspects of our own evolutionary history that made us the way we are, that you couldn't just presume that those will happen on another planet with different amount of gravity, different climate, different distance from the sun, different atmosphere. Maybe it's not even the same sugar phosphate base nucleotide DNA coding system that we have. Maybe it's a completely different coding system that arose on those planets. So yeah, I think it's improbable that we would really do too much to the past. We would probably go out of our way not to. And that's, like I said, one other thing that sort of lends credence to this time travel hypothesis over an extraterrestrial hypothesis, because they would seemingly make a great effort to contact us. If you drove to see your friend, 2,000 miles away, you wouldn't just sit outside their house and watch them with binoculars. You'd go in there and say, "Hey, bud, how's it going? I haven't seen you in a while. What's up?" So it doesn't make sense. And honestly, this might sound, I don't know. It might sound a little presumptuous, but I really think that the extraterrestrial hypothesis will be dead in the next 5 years. I don't see how it can. I don't see how it sustain itself this long. There's just too many variables, too many questions, too many things that just don't seem to add up with the idea of extraterrestrial life visiting us from another planet. And I don't know, maybe it's a little overt to come out and say that, but I think it's a flawed hypothesis. It's a flawed concept, and in the presence of one that can explain these things, I think it's inevitable that we'll sort of move away from that.
And it's so you're saying you think it's a lot more likely that it's more or less us kind of looping back and checking things out.
I do, yeah. And if you look at these reports of abductions, what they're doing to us is exactly what we would do as paleoanthropologists, as biomedical researchers. We would incapacitate them, lay them on a table, and examine. It's basically a biomedical examination, and that's what we would do. The vast majority of abduction reports describe that very same thing. Some even put it in the context of a biomedical exam, overtly stating that they feel like they were, being visited by doctors. They describe these people as doctors, physicians, biomedical examiners, and the fact that that's what we would be doing too, in the capacity of trying to learn more about our own evolutionary history, our own deep evolutionary past, where we can get more information, because we're not just digging through dirt looking for the material remains of past cultural groups, but we're studying them, their living, breathing physical form. We can study their language, we can look at their belief systems, and we're not just left to infer from what we find, a small sample of things that we find in the ground, but we can get a really broad-based, holistic perspective of their culture and biology, which is what we do in anthropology. It's the holistic and scientific study of humankind as a biological and cultural entity. We could get all of that with this tool of time travel. So yeah, I very much do think that's the case, and the whole point of the book is to lay out all of these things in one very comprehensive form to present why, scientifically, this is a better explanation for this phenomenon.
And jumping ahead a little bit, maybe the numbers I've seen, maybe roughly 35, 40,000 years ago. That's where you start to see among humans the rise of a civilization. They start building things within the next few thousand years. You see the paintings, the cave paintings, things like that, and also stories from some of those ancient people that visitors from somewhere else gave them a lot of these gifts. How do those kind of stories play into your thinking on this?
Yeah, I don't I do. There is a chapter in the book uh, that's actually called "A Brief History of Time Travelers," sort of a play on Hawking's book, "A Brief History of Time." But yeah, I look at certain aspects of our prehistoric past, our historic past, a lot of folklore, a lot of oral histories that have been passed down that describe very obscure things that don't necessarily fit with the culture of the people that lived at those times. And again, I don't think there's a lot of direct intentional intervention in the past, but just simply by being there, you would expect that to manifest itself in some way. You would expect them to recognize that it's very strange. You'd probably expect them, as people do now, to think that they came from space, because you would see this craft coming down from the sky and instantly think, oh, they came from space. But I don't feel like there needs to be this alien explanation for everything. I think we've gotten a little out of control as far as that goes. But there's no doubt that certain aspects of our historic and prehistoric past describe things that would make sense in the context of people from the future coming back to investigate people in the past. And if we're seeing it now, if it's happening now, why wouldn't it be happening in the past too? There's nothing about us, like I said, that makes us so interesting that we'd be the only time period that future humans would come to. We'd want to know about every part of the past. And there's certain aspects of us being there at those points in time that we would expect them to become manifested in the culture history of those people. The actual civilizations was a little more recent. It was mostly the result of agriculture, which was about 10,000 years ago, and it arose independently in along the Yellow River, the Yangtze River in China, Mesopotamia, the Nile River, Teotihuacan Valley of Mexico, and a couple other places, mostly because we started to domesticate crops. And that was a slow process too. I mean, you could go back possibly as far as 12, 13,000 years ago, where we just started to use crops and notice that, at least this is the dominant theory of how agriculture started, that we started to notice that they were growing up around, where we were living as we were gathering them. And then the bigger ones, the bigger seeds produce the biggest plants. So we started to select for those to get a bigger yield, and started to plant them around where we lived, and started to domesticate gregarious animals. And all of this started around 10,000 years ago. And then civilizations rose up around those, mostly because we had a surplus of food with agriculture that could allow people to divorce themselves from the burdens of getting food. Not everybody had to go out and hunt and gather. Not everybody had to work in the fields, because they could trade their time and what they were making for the surplus that's being produced by people involved in agriculture. So that gave us a whole nobility class. It gave us a ruling class. It gave us military. That military started to act to take over neighboring groups and steal their resources. And then we have an even bigger stratification in society of a slave caste now. And populations grew largely out of that agricultural revolution that began during the Neolithic about 10,000 years ago. But again, there doesn't need to be an extra terrestrial explanation there. It doesn't have to be that people from the future created this. It's an obvious step forward from what we were already doing at that time. And it helps solve a lot of problems too. We have climate change taking place. A lot of the big delicious animals that we're eating, like mammoths, mastodons, woolly rhinoceros, they were all dying out. What do you do when this really large source of food starts disappearing? You adapt, migrate, or die. And we adapted by harnessing the power of agriculture and domestication around that same time. And obviously with the climate warming, it became more possible to do so, to actually grow crops and what were previously environments that were too cold to do so.
Okay. Well, you got the book coming out. That is going to come out in the spring. That's your target publish date?
Yeah, should be around March 15th.
Okay.
Hoping that we can meet that deadline. Got some good people working on the project with me, and I certainly think we should be able to, maybe even earlier. We'll probably start doing pre-sale and early February, in fact. So yeah, it's coming up. It's almost done and almost ready to hit the presses.
And you sound pretty excited about it.
I am. Yeah, it's been a long journey. It's been a big project that and if it was just the book, it probably would have been done a long time ago. But with teaching and researching and doing these other things, service is a big part of our jobs that most people don't recognize, that professors are expected to mentor and be on committees and engage the community and things like that. But it's been a big project in the 6 years, and I'm really excited to see it come into fruition. And honestly, I'm excited about what it's become. There's been a lot of really intelligent people that have read versions of this along the way and provided important feedback and insight. It's been a very collaborative project in many ways, and I'm kind of excited as to what it's become as a result of that process.
And jumping into the UFO realm a little bit, have you gotten any feedback as far as that goes?
Yeah, definitely. I've been talking with a lot of people, mostly on Twitter. Actually, a good bit on Facebook too. I post updates from the book and little snippets as I'm going through the last content edit on Facebook, and people, have been excited about those. We just hosted a little festival the other day, and people would come up and say, "I've really been enjoying these little snippets. I'm excited about the book," and people in the UFO community too. Really interesting conversations on Twitter. Just doing interviews like this and talking to people. It's been really fun and really interesting to just continue to grow it, evolve the idea It's like I said, it's been a collaborative project working with, peer reviewers and beta readers, but honestly, just talking with people over probably the last 25 years. I remember, laying in fields, rapping with friends in junior high, high school about this same question. And it's obviously evolved a lot since then, but it's been really interesting and really enlightening for me as well.
And you went to high school. I did a little bit of background research. You went to high school not far from the Hall of Fame city, Canton, Ohio. Is that about
That's
right?
right. That's right. Yeah, Orrville, Ohio, just down the street from Canton, actually, home of Smucker's Jelly.
Okay, okay. And
Smucker's.
now you are out west teaching?
Yeah, I'm out in Montana now. I've been here for about 9 years, working at the top-rated university in the Northwest, Montana Tech, and yeah, I love it out here. It's great. So many opportunities to just get out in nature and really take advantage of what nature has to offer, I guess. So, yeah, Midwesterner living in the mountains now.
Got it. Yeah, you don't have too many mountains in Ohio, I'm afraid. I
No,
remember that from my days living out there myself.
yeah, down in southern Ohio, I was lucky to go to school in Ohio University. We had hills,
Yeah, yeah,
definitely not
Athens. Yeah, they're hills,
mountains,
exactly.
but yeah, we had a little bit to go up and down on. It was a nice place to be, but yeah, you're right. The rest of the state's mostly cornfields.
Pretty much, pretty much.
Yeah.
Well, Dr. Masters, it was great having you on this morning. Very interesting subjects, some very interesting speculations that may or may not go over with the UFO community, but interesting nevertheless. Certainly something well worth considering. Thanks so much for joining me today. It was great.
Yeah, I appreciate you having me. I would like to point out though, that I don't feel like it needs to be mutually exclusive. That, I don't feel like by explaining this with a time travel model that it needs to be something that's looked critically upon by the UFO community. I really do believe that it's the scientific explanation, that tries to avoid speculation. Um, so far has been very well received by the UFO community. And I think it'll continue to be, because it doesn't take away. It only adds to the
Yeah,
knowledge.
from what I've seen, I've been looking at this seriously, maybe not quite a decade now, and it's pretty idea driven. If the ideas are interesting, they're worth kicking around, they're worth discussing. I think generally they will be pretty embraced. I don't see too many dogmatists in the field, but that's just
There's a
me.
couple. There's
Oh
a
yeah,
couple.
there's a few, but not too many.
No, you're right. I've actually I'd definitely like to go on record saying I've been really excited so far. I mean, I've only been talking about this for about a month, but the reception it's received in the UFO community has been overwhelmingly positive, and it's been really great to work with these people and talk to them and learn from them too. Like I said, I mean, it's a growing, evolving project, and will always be. That's the main point of doing this, is to bring a new perspective and a new, rigorous scientific perspective. And I think people want that, and thus far it's been indicated by their reception. So I'm excited to work with the UFO community in this capacity.
And I don't know, you're likely aware of this, but it hasn't come up to this point. But one of the more famous cases of the last half century or so is the Rendlesham Forest case.
Hmm.
And one of the key witnesses in that case was an airman named Jim Peniston, who has openly discussed his feelings of the. It's very much time travelers from the future, us from the future. That's what
Yeah.
he feels he's encountered there. So I don't know if you're familiar with that or have had any dealings with Jim directly, but yeah, you're certainly not alone out there. A lot,
It's
you're not alone at all as far as that idea.
That's awesome. Yeah, it's good to hear. And if the chips will fall where they may,
Oh,
all I can
you
do is
weren't? Were you not aware of it? I wasn't sure if you were or you weren't.
I have heard his name. Yeah,
Okay, okay.
something about him touching the craft, and
Yep,
and he
yep,
received
yep.
this sort of flash, and understood that they were from time rather than space. So, Yeah, and then you had on your show recently one of his colleagues,
Right, John Burroughs, right? We
John
did, we
Burroughs.
did.
Yeah, I
Yep.
listened to that interview. It was a really good episode of the program. But yeah, no, it's not an idea that I came up with myself. I thought of it independently when I was 8, but it's an idea that has been around, and I think in the near future it's going to become a more prominent model to explain this phenomenon. But like I said, all I can do is put out the research that I've done, build this case, and then looking at the research of others collectively going forward, just try to make sense of this mysterious phenomenon.
Got it. Well, continued good luck to you, and we'll look. Do you have a title set for the book yet?
Yeah, it's called Identified Flying Objects.
Identified flying objects. So we'll look for. I'm assuming that when it does come out, the easy spot is Amazon, but there'll be others as well where folks can pick it up.
Yep, all major distributors. Amazon's probably the easiest and the best as far as that goes. But yeah, it'll be widely available for sure.
Fantastic. All right. Well, Doctor, you enjoy the rest of your weekend. I'm going to try here. You got the being out west. You got a little bit more time ahead of you today. But thanks so very much for joining us. And we will have some more shows in the future. My co-host James, who's on assignment again this week, says he's got some good names for us lined up. So everybody, by all means, tune in the future. Tell your friends all about it. Doctor, thanks once again for joining us.
Thank you so much. I appreciate you having me, Frank. It's been great talking to you.
Thanks a lot. You have a great day. Bye-bye
All
now.
right, take care.
And that's that. We will be back in the future, just like our future friends. So you have a good day, everybody, and thanks for joining us. Bye-bye now.